All right, here we go. Unit 5, Lesson 2. We're going to have another day working with the quadratic formula, and this time we're going to be working with quadratic functions that don't play so nicely with it. What I mean by that is every time we've had a problem where we were asked to apply the quadratic formula so far, we've worked it out, you set everything equal to 0, you figure out your a, b, and c coefficients, and along the way, right, part of that quadratic formula is plus or minus the square root of b squared minus 4ac. Until now, that b squared minus 4ac part, the part that is under the radical, under the square root sign, which is known as the discriminant, has only been a perfect square. So 0, 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, etc., right? Because those are 1 times 1, or 2 times 2, or 3 times 3, or 4 times 4, or 5 times 5. They are all things such that we could take, for example, the square root of 36, and we'd have 6, right? So plus or minus the square root of 36 would be just plus or minus 6. Now, these things aren't all going to play so nicely, right? So we're going to talk today about a few examples where that part under the radical doesn't always work out to be a perfect square. So here's just one more example, just to refresh our memory, or if you're jumping into this late, right? This is an example of a problem you had to solve on Desmos yesterday. Given 5d squared plus 10d plus 8 equals 2d. One of the methods we have to finding the solutions to that equation, instead of factoring, is to apply the quadratic formula. So you get everything to one side and set equal to 0, and then you can use the quadratic formula, which again is not something you have to memorize. It'll always be given to you. A, B, and C, 3, 10, and 8 there. So we work this out, and you get b squared minus 4ac on the inside, and you do that math out, and you get the square root of 4. The square root of 4 is a perfect square, so that square root of 4 becomes plus or minus 2. And so you branch this off into its two possibilities, and you have negative 10 plus 2 over 6 and negative 10 minus 2 over 6. Now, these don't always work out to be whole numbers, right? And they haven't so far. So in this case, you do the left-hand side, that becomes negative 8 over 6, which if you divide both the top and the bottom there by 2, right? You're allowed to do that. If you do the same thing to the numerator and the denominator, it's still the same fraction. You get one answer is negative 4 over 3. The other one divides evenly. Negative 12 divided by 6 is negative 2. So those are your two solutions. Let's take a look at one where we don't quite get the same ease of taking the square root, and we'll recall some things that we can do to simplify from Algebra 1. So here's another example, right? This is again just pulled straight from Delta Math. If we have m squared plus 4m minus 9, right? And the reason the quadratic formula is helpful is you can sit here and you can bang your head against the wall as long as you like. You're never going to really come up with two numbers that multiply to make negative 9 but add to make 4. And the reason for that is because they don't end up being rational numbers. They end up being square roots that we cannot simplify any further. And so we apply the quadratic formula. A is 1 from the 1 in front of the m squared. B is 4. C is negative 9. We work this out, right? You're doing a bunch of these, so I don't need to work this all out. That's why I'm just taking this right from the part that's important today. And you get to this right here. You get to the square root of 52. And so the square root of 52, well, that lies between two things that we know. We know the square root of 49. 49 is 7 times 7. And we know the square root of 64. That's 8 times 8. So it's somewhere between 7 and 9. As a decimal, it goes on forever. It never repeats. It approximates to 7.2. It approximates to 7.2. If you were not asked to simplify, right? If you were not asked to simplify this, this would be a fully correct answer. However, right, just like we don't leave things as we don't leave things as like 4 over 12, we'd say 1/3. There is more that you can do here to simplify. And I'm going to have to remind us of a technique from Algebra 1. if we take this square root of 52 and we think about it, right, one of the things about square roots is that if we can break up their insides into factors, right? So let's think of factors of 52. We'd have 1 times 52, we'd have 2 times 26, and the one that I'm going to care about is 4 times 13. The reason I care about this is that if I turn the square root of 52 into the square root of 4 times 13, well, really what that is, right? This is a rule of square roots, is this is the square root of 4 times the square root of 13. And the square root of 4 we do know. So this is 2 times the square root of 13, or commonly written 2 root 13. Now, I won't write this out every time. The way you'll see me do this is I'll kind of underline this perfect square here, and I'll show an arrow to show that I am taking the square root of it to remove that factor. And so you'll see me take that 4 out as a 2. But really what's going on is this. I'm breaking this into the square root of 4 times the square root of 13, and then I can just take the square root of 4. So what you would see me do here is the following. Negative 4 plus or minus the square root of, one line I'd write on my paper, 4 times 13, all over 2. And then I would draw this arrow showing that the 4 is a perfect square and can come out. So what we have here, right, next line, negative 4 plus or minus. Don't forget, when this comes out, right, you can't take it out of the square root without actually doing what the square root is. So the square root of 4 is 2, and the 13 is left on the inside. So we have negative 4 plus or minus 2 root 13 over 2. And another reason we have to do this is that this wasn't fully simplified, because now, as you can see, we've got 3 terms, right? 3 things that are discrete terms. We've got the negative 4, we've got the 2 root 13, and we've got the 2. And when all 3 of those things have a common factor, in this case, they can all be divided by 2. We want to do that. So negative 4 divided by 2 is negative 2, plus or minus 2 divided by 2 is 1, times the square root of 13. Or, just written more simply, negative 2 plus or minus the square root of 13. And that's how you would enter it on Delta Math. There's a little plus or minus button for you to do that. Okay, I want you to just see one more example here of that working out in practice. So let's say, all right, last example here, and it's kind of worked out all the way till the end. Oh, actually, sorry. There's one more thing I want to say. The radical is not always going to simplify. And so say you had this other problem, you work it all the way out, and you get down to this stage of 73. And so what you want to do when you're doing these problems, you want to keep on hand, right, just a reminder sheet of all of these perfect squares until you've got them really down, right? You've got 1 times 1, 2 times 2, 3 times 3, 4 times 4, and so on and so on. What you need to do before you say, okay, I'm done with this problem, is you need to think for yourself, okay, do any of these things, 7 times 7, do any of these perfect squares divide into 73? And you only have to go up to the one that's below 73. And so in the last case here, this would be 64. Well, 1, well, that doesn't divide into 73. 4, 73 is an odd number, so no way. Okay, 9 I have to check. I have to think about. Okay, 9 times 9 is 81. 9 times 8 is 72. So nope, no 9. Again, 73 is an odd number, so no 16. 25, no, because that goes into 75. 36 times 2 is 72, so that's not right. 49 doesn't. So none of these do. This would be a final answer on Delta Math, because there is no more simplification to do. There are no perfect squares you can take out of 73. Okay? So 73 was not divisible by any of these perfect squares, and we are done. Obviously, part of the work today is just making sure you can go through those perfect squares and figure out which ones do and do not, or which ones are and are not divisible into the discriminant. Okay, so here we go. Last example, just to here's a full example of one done out. If we have 4b squared minus 8b minus 1 equal to 0, and I want to find solutions. The quadratic formula is a good method to use here. We are already set equal to 0, so I would say my A term is 4, my B term is -8, and my C term is -1. So using the quadratic formula, we would have negative B. All right, this is that technique I like to use to avoid mistakes. I just put a parenthesis, and I will fill them in later. I put a parenthesis for every single variable here, and then I go back and I fill it in 2 times A. We'll leave that out. All right, so negative B. B is -8, so that's going to become a +8. Square root of -8 squared minus 4 times A is 4. C is -1. All over 2 times 4 is 8. Okay? So working this out, we'd have 8 plus or minus the square root of -8 squared is 64 minus 4 times -1, that's minus 16, all over 8. Okay, getting further along, 8 plus or minus the square root of, this is 48, and feel free to use a 4-function calculator if that's going to slow you down to do things like that, all over 8. And now this is the new part for today. Again, 48, not a perfect square because it lies somewhere between, if I write these out, 1, 2 times 2 is 4, 3 times 3 is 9, and so on and so on. It lies somewhere between 36 and 49. So it's somewhere between 6 and 7. 49 doesn't divide in, 36 doesn't divide in, 25 doesn't divide in, but 16 does because 48 is 16 times 3. So we have 18 plus or minus the square root of 16 times 3 all over 8. And the square root of 16 is 4. So this is equal to 8 plus or minus 4. The 16 comes out as a 4, right? Because you take the square root of it all over 8. Now, remember here, 1, 2, 3, all 3 of these are divisible by 2. So I'm going to do that. I'm going to divide everything by 2, just like I'm reducing a fraction. This is 4. Actually, they're all divisible by 4. Even better, they're all divisible by 4. So we're going to have 8 divided by 4 is 2, plus or minus 4 divided by 4 is 1. So just the square root of 3, 8 divided by 2 is 2. This would be your final answer on Delta Math. Now, there is one thing you want to watch out for. Sometimes, if you don't find the highest root that comes out, you can accidentally think you're done when you do one stage of these. So this is one method to take, but say you went from the bottom up and you didn't get to 16. You said, okay, 1, that doesn't matter. But then you said, okay, yeah, 4. 4 goes into 48. So I could have another method of doing this, is to say that this is 8 plus or minus the square root of 4 times, in this case, 12 over 8. And you take the 4 out, and we get 8 plus or minus 2 times the square root of 12 over 8. Those are all divisible by 2, so we'd have 4 plus or minus the square root of 12 over 4. But the problem is here, this was divisible by 4 twice because 12, all 12 is 4 times 3. So if you stop there, it's not fully simplified. You'd have to do this trick again. This is 4 plus or minus 2 root 3 all over 4. Final answer here, when you divide those all by 2, 2 plus or minus the square root of 3 over 2, exactly the same as we would get if we took 16 out first. So just a warning that if you don't find the highest root to take out first, you might have to repeat that process. All right, so that's it. The Delta Math today is to just do, I think, 4 of those. Get your practice in on that before tomorrow will be finally the day we move on to complex numbers.